Hello, this is Mr. Weideman. I'm here to help you on problem number 10 of our test review problem set for our test coming up on one-dimensional motion. This problem here is what I call a typical catch-me problem. What I have here is I have a truck moving along at constant velocity, and I have a motorcycle that is initial velocity 0. It's at rest. What happens, this truck is just going to continue to move along at constant velocity, but as soon as it passes the stoplight, the motorcycle is going to begin to accelerate to try to catch it. Now, the truck is going to have a bit of a head start because he is already moving. Okay, the motorcycle is going to have to start from rest. He's going to have to get up to speed, and he's going to have to move faster than the truck in order to overcome it. So a lot of people, when they solve catch-me problems, they say, oh, I've got to match the velocity. That's not true. Let's see what happens here. So the truck moves on past. The motorcycle accelerates to catch it. And then when they do catch each other, there's two particular pieces of information that we're going to use in order to solve this problem. The two pieces of information that each is going to share is that from the stoplight, I need to put my reference point at the stoplight. From the stoplight, they have both covered the same distance. That's how I know that I've caught you. I'm in the same place at the same time as the other person. Another thing they share is same time. If I again set my reference point for my time at the stoplight, the amount of time that the truck has moved away from the stoplight is equal to the amount of time that the motorcycle has moved away from the stoplight. All right, so I've got two kinematics pieces of information that I can use to describe the motion. Motorcycle and truck have traveled the same distance from the stoplight, and it's taken them both the same amount of time from the stoplight. But they're doing two very different things in between, but that's okay. Okay, so let's start with this. I'm going to say the distance of the motorcycle is equal to the distance of the truck. All right, so I'm using equation number 4 here. And here on the left side, I'm going to plug in all the information for the motorcycle. On the right side, I'm going to plug in all the information of the truck. I'm going to set them equal to each other because, again, they are both the same distance away from the stoplight. Okay, the motorcycle starts at rest. I'm given his acceleration. The truck, I'm given his velocity. Notice he doesn't have any acceleration. So actually this equation becomes quite easily to solve, and I can find time. Now, once I have time, I can plug it back in to my distance equations and find out exactly how far they are away from the stoplight. And given that element of time, I can basically back calculate anything else I need to solve this problem. Okay, this also is good is, let's say the truck is not moving at constant velocity. Well, that's okay. I can still plug in a velocity here, an acceleration here, and still solve the problem. What if the motorcycle was not at rest? No big deal. I just have a value in there, and I can still solve the equation fairly easily. Okay, so make sure that you learn this for tomorrow. Also, look on Edmodo for the answer key for all the problems for the test review. And good luck.